What's up everyone, this is Dariusz Kalbarczyk, co-founder of MG Poland, JS Poland, AngularMaster.dev and WorkshopFest.dev. Welcome back to the Angular Master podcast. Today we've got a special guest straight from Warsaw, Poland. Staff software engineer at Google. He's working on the largest Angular application. Ladies and gentlemen, Łukasz Jancewicz.
Glad to be here.
Hi Łukasz, how are you?
Doing great. How are you doing?
Perfect. So for those who don't know yet, please tell us about yourself.
Well, I'm a software engineer at Google, have been for 7 years now. I work on Google Cloud Console, which some people say is the largest Angular application in the world. Well, I'm a huge Angular enthusiast. I have been working with Angular for a very long time, even before Google. I also like to evangelize a lot. So I promote coding best practices, testing. I guess that's it.
Perfect. So can you tell us about your role at Google and what a typical day look like for you?
Sure. So as a staff software engineer, I do lead some important projects related to Google Cloud Console. One of the projects right now, for example, is making our pages accessible. At the same time, I do a lot of evangelizing and education. I have a bi-weekly training session where I teach people about interesting aspects of software engineering, and Angular is a frequent topic there.
Amazing. So the most important question, how did your adventure with Angular begin?
Oh, sure. So as I was saying, in my previous job, we were transitioning from a client-server application written for Windows into the web. We tested out various approaches, and we weren't happy with the complexity that came with creating a web application. That was some time ago already. And then we encountered Angular. It was version 1.3 at the time. And I remember the legend of Miško, who promised to deliver an application in 2 weeks using an innovative framework, and supposedly did. I dug into it and I fell in love with Angular and have been an Angular developer ever since.
That sounds amazing. So let's talk about challenges you faced working on this world's largest Angular application.
All right. So, of course, the challenge is scale. On one hand, this is a great benefit for us because we often get to talk directly to the Angular team, being one of or the biggest Angular client at Google. But anything that we need to do, we need to consider how it fits into the bigger picture. This, I think we're going to get into this later, maybe, but testing, releasing, developing, even planning changes like migrations, all of that needs to take into consideration the fact that we are big and we need to maintain release velocity, consistency. I would say it's not as easy to change things as it is in a smaller application. That would be a very polite way of saying it.
Okay, so how you and your team prioritize features and improvement in such a large-scale project?
Sure. So there's two kinds of work that needs to be done. There is feature work, meaning there are product requirements. We need to improve our existing products or add new products into Google Cloud Console. And this actually comes from top down, right? So we have program managers, product managers essentially telling us what people need and working with us to implement those features. On the other hand, there is always infrastructural work to do. Integration tests start being flaky because there's too many of them. A library needs updating. An API became obsolete. With a larger and larger code base, we need to spend significant time addressing those issues. Okay, maybe the third interesting source of work is horizontal efforts. So, for example, let's take accessibility. Suddenly, it turns out that there's both government regulation and market demand to make all of our pages completely accessible. And this is not something that a single project team will fund. It's simply impossible. This project is too large. There's something called a horizontal planning and horizontal effort, which mandates that every team spends some chunk of their time addressing this important problem. And I'm part of the team that handles horizontal efforts so that others don't have to. So that's, I would say, the third source of incoming work.
Amazing. Can you share some insights into the architecture of this massive application?
Okay. So a little bit of history. Cloud Console used to be a small application, started really modestly back when cloud was not a big thing yet, and I don't think anyone suspected it was going to grow at a pace that we are seeing right now. Fast forward 5 years, it was an application with a few million lines of code, several hundred developers working on it. And today, that's over 4,000 Angular routes, 4,000 Angular routes, that would be too many. 2,000 developers working on it, and I think over 15 million lines of code. A project of that size, around 5 years ago, it turned out that we can't maintain it anymore without spending significant effort every day just to make a release happen. To understand why that is, let's look at a release cycle, right? So we have a code base to which many people contribute, and imagine that we need to create a binary out of it. A single Angular binary like that is going to be extremely large. It's also going to build extremely slowly. And if there's any bug anywhere, it's going to stop compiling. And even if it compiles, if anyone made a single mistake at runtime, then some test is going to fail. And so, we have a release process where we push the candidate to first to an auto push environment. We run unit tests on it. We push it to staging environment. We run integration tests on it. We run end-to-end tests before releasing. If any of these tests fail, we need to go back, investigate, and if this is a real bug, then we abort the whole release and wait for the fix. Now, with a single build, that was unmaintainable. And so we had to split. The way we did this is very similar to what people usually do, which is we went to Microfrontends architecture, but we added a Google flavor to it. So one Angular application now hosts the main index.html loading and the shell. So that's the upper and left part of the Cloud Console. The actual content of the page, what resolves in the route is rendered separately. The way we did this is there is a hidden iframe into which we load a completely new Angular application that has a separate set of libraries that have nothing in common with the shell application. Except the iframe is not rendered on the user's screen. It's instead hidden off screen, and it's patched in a special way so that all the DOM operations like create element, add event listener, they are forwarded to the mainframe. And so from the user's perspective, the page is a single DOM tree, which is great for usability because you can then, make it narrower, wider, without all the hassle that comes with working with iframes. At the same time, the separation between the two iframes means we can now release independently. And that brings all the benefits. Because look at the disadvantages that I spoke about before. The binary is now small. There's only Angular core plus anything my pages need, like my team's pages, let's say networking pages on Google Cloud Console. It compiles quickly. There's a lower chance that there's going to be a compilation bug in it. If there is a runtime bug in my application, I have to fix it. But the sister team that does, let's say, compute doesn't care. And they can continue with their release process. So a problem in one of the microfrontends doesn't impact the release pipeline of other teams. Now, this does come with drawbacks. If you imagine a user experience of a user moving between networking and compute pages. Let's say you visit a network and you want to see virtual machines that are defined on that network. So you click on a link to see details of a virtual machine. You're now transported to the third Angular application. This does incur a loading cost. If you're moving quickly between the two, the user expects to have a smooth transition. So actually up to 5 Angular applications are running at the same time, just in the background in various iframes. And it would be nice if they could share code, right? So let's say both applications would like to know details of the current Google Cloud project, name, ID, permissions, etc. It doesn't make much sense for the second microfrontend to load the same data from the server. So we have a cache. The cache is shared between the microfrontend applications. And it's a very delicate cache. Why? There's a problem with version skew. Imagine that you slightly change the library that accesses the cache. Let's say you want to add a new field to the project. Now, depending on which team releases first, that team is going to start inserting updated data into the cache, but the other team doesn't expect it. It's easy to write code that will make some microfrontends crash when trying to read the cache. And then it's a big mess to untangle because you have 200 of these microfrontend applications, and patching them all together and involving everyone from their release processes to help fix that is a big effort. So we have some checks and balances in place to make sure that every time we touch code that touches the cache, we are trying our best to avoid these situations. But they do happen sometimes.
Clear. So how does your team manage performance optimization in this amazing application?
Sure. So performance is an interesting topic because everyone understands something else when they say performance. For us, at Google, we have a program, well, I call it SLO program, so service level objective, where each page by themselves define how fast they expect their pages to load. Cold load, hot load, how fast they expect their interactions on the page to occur. And also, what's the allowed percentage of JS errors or server request errors from the whole set of interactions. This is interesting because with 200 smaller teams contributing to Cloud Console, you can't really mandate these numbers top down. And also because some pages are inherently more complex than others, and expecting the same performance from them wouldn't really be feasible at all. So each page gets to define their own barriers, and we have alerting, meaning automated. Okay, first we have monitoring that measures every time a user goes into the page, their load time, any errors that appear, they are being aggregated into monitoring. And then we have alerting that if the error levels or exceed certain threshold or latency drops below a certain level, latency grows is wrong. So if latency grows beyond a certain level, then we have an alert, an on-call is notified, and we investigate, we make the problem go away. This is how we do performance. And we are encouraged as teams to work to make those thresholds tighter. Right, so every year we're trying to make the page load a tiny bit faster, to make it a little less, have a little less errors. Now, a good question someone might ask is, why do you even allow errors at all? Shouldn't the threshold be 0 errors, never error? Well, that's completely infeasible. You cannot have a page that doesn't error out. First problem is this is a browser. And who knows what plugins a user has in their browser. Some people, have plugins that try to mess with the HTML. Some people have plugins that mess with our JavaScript. They have firewalls in their networks, which block some of our requests, which completely breaks Cloud Console, and especially with regard to icons. And at that level, we as Google, we cannot know if it's our fault or it's the user's plugin's fault. We just get the JavaScript error and we need to investigate the report. And even if this is our fault, right? A server responds with a 500 or it's overloaded, that will happen. Those servers also have a service level objective that needs to have a margin of error. Otherwise, no innovation can occur. It's just a fact of life to set this low enough so that users are still satisfied, but high enough so that fast development can happen. Hope that makes sense.
Makes sense, of course. Which development process and tools are essential for managing your workflow?
So I'd say I particularly enjoy our release pipeline. As I said, we do we have several environments through which every one of these 200 microfrontends go through when going into production. So first, we have a continuous integration unit test suite, which runs on our code base. If that test suite returns green, everything is passing, we cut the candidate binary. So we say, okay, this is a good candidate for a binary release. And we move it into the auto push stage. Then normal development can happen, but this candidate's road, like the train has departed. Now this candidate is on its way to possibly being promoted to production. First, it gets promoted into staging environment. There, integration tests are run on this candidate. If they don't pass, then sorry, this is not a good candidate for pushing further. We wait for another cut from our main source repository and then try again. Of course, there's someone monitoring this process and they investigate the test failures that occurred. They have a possibility to manually override any failures if they see that this is just a flaky test or something. But we're actually discouraged from doing that because we want this automation to run almost without human intervention. This is the best way for everyone. Anyway, if the integration tests pass, then we promote the candidate to production. But even then, we don't do it all at the same time. We don't upgrade all instances of Google Cloud Console with this new binary all at the same time. What we do is we deploy to a thing called canary servers, which are closely monitored by our monitoring and alerting software. And we look at signals like latency, availability, SLO stuff that I spoke about earlier, crashes of the binary. If there's anything alarming, again, the rollout is paused, someone is called to look at it. If everything is fine, the automation proceeds, and then we roll out to progressively to 10, 50, 100% of users over several hours. If anything on the way is wrong, we can always roll back. I feel like this gives developers a lot of confidence that if they write their code and test it thoroughly, they can be sure that if there's any problem, they will be notified and the users will not be affected. So I'd say this is the best thing that helps us in our workflow. A lot of this happens automatically behind the scenes and many people are not even really maybe aware. But at a project of this scale, this is invaluable.
So how about testing? How you manage testing for this amazing big application?
I like how you say amazing all the time. I do find it, surprising that an application of this size can, actually work. But it's an effect of dedication of many developers. Testing. So we have 3 kinds of tests. The standard testing pyramid applies at Google very, very much, simply because we have so many lines of code.
How many?
I think 16 million. That's including tests, but still, it is a lot. So in small applications, it makes sense to maybe just end-to-end test everything and be done with it. In Google Cloud Console, if we tried to test everything end-to-end, we would never release anything, simply because end-to-end tests have an inherent flakiness in them. And by flakiness, I mean they sometimes fail for no reason at all. The reason why end-to-end tests are flaky are numerous. The browser clicking is not always ideally precise. Network connectivity can drop at any point in time intermittently. A server might decide that this is the time that they will return the 500, and once out of 1,000 requests or 10,000 requests they return a 500. But if you have 20,000, 50,000, 100,000 end-to-end tests, that means that guaranteed 100 of these tests will fail. So this is not how we do things. We start with unit tests. At Google, we have a mono repository. Okay, this is a tangent, but we have a mono repository at Google. That means that people don't use branches. Actually, that doesn't mean that they use branches, but we don't use branches and we have a mono repository. The implication of that is every time someone adds some code to our mono repository, they add unit tests at the same time, because this is the first and last moment that they can do this. There is no, I will add tests later. We don't do that here. Always you add unit tests when submitting code, even if that code is never used anywhere yet. And we build on that. So we have an enormous coverage of unit tests for our code. Then there's integration tests. Those are the tests that are Angular agnostic. They don't use Angular features. This is actually, we're using WebDriver, so it's like a library that fires up Chrome and simulates clicks and key presses, and it could work with any web application. We have our own additions to it to make it easier to write. And of these integration tests, we have two flavors: hermetic integration tests and true end-to-end tests. Hermetic integration tests test our application, but they don't use real backends. So cloud backends are servers that do the actual work. They start virtual machines, they create disks, they create Kubernetes clusters. In hermetic integration tests, we fake all that with simple Java classes that just use dictionaries and pretend they do work. These hermetic integration tests, I feel like they are our greatest asset because they allow us to end-to-end test our part. Our meaning front-end developers part. Angular, its interaction with the middleware server, and that middleware server interaction with the backend, but they ignore a whole source of flakiness that is the real Google Cloud APIs. And then we have end-to-end tests, which is just what people would expect. We test on real things. We have fake projects with real resources in them that we create, delete, and then manipulate to test our scenarios. And as I said, the number of unit tests is the largest. Then there's hermetic integration tests. There's a lot fewer of them. And finally, real end-to-end tests, we try to keep that number low. We must have some to be aware of unexpected changes in Google Cloud APIs. But it's always a debate on whether a certain integration test should be hermetic only or also be end-to-end test.
What was your most challenging problem at Google and how you solve it?
Okay. That for sure was migration to a new version of Angular. So you might remember that Angular came from version 1 point something to version 2 and changed completely with version 2. This was a much needed change and a much needed upgrade of Angular framework. But for us as Google Cloud, it was almost a complete rewrite of our code base. With several million lines of code, you can't just stop all development and say, okay, now everyone migrates to Angular, no development for a year. This wouldn't fly. We had people protest, and say, users need features, the business needs fixes. You can't just pause everything and rewrite. So we had to do this piecemeal, page by page. And the part that was interesting to me was that there was an idea made by my senior colleague, Onufry. He proposed that we write a tool to automatically migrate templates and controllers from AngularJS to Angular. And it was very funny because I wrote a huge doc explaining why this is entirely impossible. And then I was leader of the team that wrote the thing. So it was a huge success. It turned out that the tool didn't solve all the problems, but it migrated 80% of every page. So we had an AngularJS template, we ran it through that tool, and we had an Angular template that required, 10 fixes in various places. And because we had such big unit test coverage, we had a very easy way of verifying if we did the correct job or not. So we just made the code compiled, and we made the unit test compile after running the tool, instead of just rewriting everything from scratch and then thinking about what we should do in every step of the way. The reason why this was a success, I think, was every time you are tasked with rewriting something, a developer has a tendency to think, and while I rewrite this page, I remember I wanted to fix this, this, and that. So there's scope creep is a real thing in migrations. But when you have a tool that does everything automatically, that tool doesn't have that thought. So you end up with a page that has exactly the same set of logic that the original AngularJS page had. So yeah, that was my most challenging project. In the end, the migration was successful. It took us almost 5 years to migrate all of Cloud Console to Angular.
That sounds crazy.
It was.
So how does your team handle scalability and ensure the application can handle an increasing number of developers and code size?
Sure. So I already told you about the split into Microfrontends. The other things that come into place when managing an application of this scale is standardization. We want everything to be similar, even with 200 teams working on it. So we have a centralized team responsible for creating design language and common components, Angular components, which fulfill this design language. And every team is expected to use those components so that their pages look and work similarly. Also, many things are centrally, not, I wouldn't say mandated, but guided. There are tutorials and examples on how to do certain things. For example, how to do forms, how to handle backend API connections, how to show errors to the user. The more things are the same, the easier it is to maintain an application of this size, and also to make migrations, which I already mentioned is like the biggest pain point of any development really at scale.
Definitely. What are some key lessons you learned that from working at Google that other Angular developers could benefit from?
Okay, so one thing that comes to mind is unit test harnesses. This is an idea that was a revelation to me when I first heard of it at Google. It goes like this. When you create a common component or a common service to be used by multiple people, they're going to use your component in their code, and they're going to also test your component's behavior in their tests. You want to make sure that they test your component the way you want. So along with that component, you also publish a unit test harness. That unit test harness is a layer of indirection which allows everyone to easily test your component's behavior. So for example, let's take a select component. You want to have an API to check what's the current value of the component, what is the list of options available, is it disabled or enabled, is it required or not, etc. If you give developers this harness, they will happily use it because they don't have to look at your component's internals and figure out how to check this with, DOM queries or some other XPath queries, hacky inspections into component attributes. They will just use your harness. And now, as a component owner, you have very big power because you can change how the component works internally. And if you change the harness at the same time, no one will notice. No test will break. Everything will keep working. Of course, this works if everyone adopts using harnesses, because if there's some people who just ignore the harness and then do the hacky stuff, then their code will break when you change the component. But still, I believe it's very easy to write a harness. The only hard thing is you need to convince the author of the component that it's worth the time investment, right? So when writing a common component, think about an upgrade path. How will you upgrade this component? And there's a very high chance that if you have a test harness, your upgrade is going to be easy.
How do you stay updated with new Angular features and integrate them into your project?
Okay, that's an easy one. So because of the mono repository and the Google philosophy, we actually have only a single version of Angular library in our codebase. And because Google owns Angular, that version of the library is actually a copy of GitHub main branch. That means that every new feature that Angular pulls into the main repository appears almost immediately in our Google code base. So we can start using it. That means that, as with all things at Google, the onus of making sure that nothing is broken falls actually on the Angular team. What they do is they can run a suite of tests at Google to make sure nothing at Google is broken with their Angular change. And that includes unit tests of Google Cloud Console. So when they add a new functionality or they fix a bug, they can be sure that we are not broken. So this is easy. However, there are other libraries that Google does not own, and this policy still applies. There is only a single version of that library in our code base. If you want to upgrade that library, which you should, you need to actually go through a multi-step process, which involves first looking at what breaks when you update the library, going through all the places and all the products that use that library and patching them so that they work both with the old version of the library and with the new version of the library. This can actually happen over multiple commits. It can take some time. Doesn't have to be rushed. At some point when you think you're ready, you try to flip the version of the library. You upgrade the library and see if anything breaks. At Google, we have a very generous rollback policy, which says you can roll back any change that breaks you. So if there's something that's still not working, roll back, fix that thing, try again. It's part of the process. No one's getting angry. At some point, you will succeed in upgrading the library, and then you clean up any branching statements, if statements that you put into the code to make your code work with all the new version library at the same time. So that also can be done at a slow pace. And this is actually how we do a lot of things. A good example is TypeScript, which is updated pretty often. The TypeScript team releases a minor version, every month or two. And we have a team at Google that tries to catch up with them pretty quickly. And this is the process that they use.
Could you talk about a recent feature project or project you worked on and what made it interesting?
Mm-hmm. So I already spoke about accessibility project that aims to make all of the pages that my team is responsible for accessible, meaning mainly that they work for people using screen readers and they work for people using keyboard and not having access to a mouse. At the beginning, it was very challenging to move forward at all because so many things were not working. And if you think about it, it's not surprising. The web is kind of designed first for the sighted user with a mouse. But as we went along and we upgraded our common components and we upgraded our modes of thinking and we educated people in what accessible means, it became easier and easier to fix every next page to be accessible. And actually, like baby steps, one at a time. Think about fixes like, if a field is disabled in a form, there needs to be information on why it's disabled or how to make it enabled. Or, when you press enter to open a drop-down, there must be a key you can press to escape the drop-down and to move to a different place. Or if you focus on a tooltip, that the title of that tooltip should tell you what will happen if you open it. What will happen, basically. All of that stuff is super useful not only for disabled users. If you look at the page before we started our effort and after we finished, it's like two different pages. And the latter is so much more usable because even without any disabilities, the fact that the page is now laid out better, has better explanations, better focus management, it doesn't jitter and jump all the time, makes for a so much better user experience. This was something that I did not expect. So huge encouragement to everyone. By making your pages accessible, you are making them better for everyone using your pages. And it is very, very satisfying to see.
How does Google encourage innovation in your team?
Okay, so the short answer would be it doesn't, but that wouldn't be entirely true. We can look at it from two sides. First one is we have amazing developers who are always interested in the new thing and they want to try out stuff. And there is an environment that encourages that encourages experimentation. I already told you about our test coverage and about all of our programs. So people want to try out stuff. They realize there's now a new, easier way to improve lives of others and of ourselves. And they push bottom up on initiatives to innovate. From top down, there are programs that encourage this kind of stuff. Two good examples. There's a program that encourages improving performance, meaning every half a year or so, you're entitled to submit like a bragging doc that says, hey, I improved this page by 20x by changing these 2 lines, look at me. Or a separate program that looks exactly the same except it rewards code health. So, hey, I changed these 100,000 files to be shorter, more elegant, easier to read, whatever. Same for other aspects of coding. And then you can earn awards, and those awards are sometimes physical. You can put them on your desk. And sometimes it's like cash awards or other things like that. So we are not mandated to innovate, but we are encouraged to find innovative solutions ourselves, and sometimes we're rewarded for it. And it's a lot of fun to participate in such contests.
That sounds good. What advice would you give to developers looking to scale the Angular app?
Okay, so first of all, our Microfrontend solution is not open source, which comes with its own drawbacks. So you can't use that. And we are also evaluating our usage of this because it's non-standard. Having said that, I would discourage anyone from going into Microfrontends too early. My rule of thumb would be somewhere around 2 million lines of code. Okay, maybe for some people it's only 500,000. Maybe for some people it's going to be 4 million. Not sure. Somewhere around 2 million lines of code is the threshold at which you need to seriously think about splitting your application into smaller parts. But if you're just starting, doing Microfrontends will slow you down significantly. There is a high chance that you will split your binary in a way that's not really needed, or you will separate logical parts that should have been together, that they don't have any performance gain or build gain or release gain from being separate. And you only get problems with version compatibility. There's multiple ways to achieve micro-frontend architecture. I believe everyone should try out various strategies and see for themselves. But first, make your app large. Find your users, scale your app as a monolith. That would be my advice.
Could you share how your team approaches collaboration and communication in such a large and diverse environment?
Okay. So we have Gmail, and we have Google Chat, and we have Google Meet, and we use those extensively. So this is no surprise to anyone. Google's collaboration tools are used in-house. very extensively, and email, chat, and meetings are in constant use. Having said that, we do have some innovative things. I think the best thing I like at Google Cloud Console development specifically is we have a bunch of steering committees, meaning senior people meet regularly to discuss the latest challenges and propose paths forward, which are then implemented. And this allows for some degree of cohesion, or keeping things standard, keeping things common, moving in the same direction, even though there's 200 organizations and everyone has their own priorities.
What are some of the common misconceptions people have about working on large Angular app?
So one of the biggest complaints that we get from people who start working for Google Cloud Console is that things happen slowly. They would like to see their code working for the client immediately. Who cares about tests and release processes? But as I told you, even if in the most optimistic scenario, if a change is committed into our repository, it takes at least 2 days for this change to reach the client. And that's for teams that release daily. And if you try to do something that looks like a very simple change, let's say you want to add a CSS class, then you are stopped by hundreds of pre-submits, automated checks that we run before any change is committed to our repository. And this feels frustrating to people because maybe they're used to, university life or startup life where everything happens very quickly. But you need to remember that every one of these checks and balances, they were added as a consequence of a post-mortem that happened because someone had a problem because someone else did a change like that. However, with a change of mindset and, making peace with the fact that some things you just cannot do and some things just take time, you can change your workflow into one that just lives with this situation and, make the best of it. And at some point, you start seeing the benefits that all of the things that were made to make your life easier and to make sure that you don't make mistakes are actually there.
How do you measure the success of your application and team's performance?
So there are these SLO thresholds that I told you which measure performance. We have the accessibility certifications that are made by independent vendors that give us a confirmation that our pages are accessible. For feature development, there's some analytics in place that we put to see how many people succeed in finishing some critical user journeys in our product. We do user feedback surveys. And for team success, I don't know. I'm not a people manager. I lead my teams on a more technical level. So it's hard for me to talk about evaluating people. I want to believe that my team is very successful and I enjoy working with them very much.
What are some upcoming trends or technologies in Angular development that excite you?
Right. So I was excited very much about signals, and I like the way where it's going. The thing that I am waiting for most is signals in forms. Forms has been a big part of my life as Angular developer. I feel like I know this area pretty well, and I feel like there's much opportunity for improvement in form design, especially when it comes to reusability of form subcomponents. And with signals, it feels to me like the way forward is very clear and bright, because signals discard the idea of top-down change detection, whereas a form is inherently bottom-up propagation. The conflict will stop occurring. And so working with forms is going to become much, much easier if they are all signal-based. So I'm really, really hopeful that we'll see signal-based forms in Angular really, really soon, and I'm excited to see it. From other recent Angular changes, I love the atlet statement. It makes templates so much nicer.
My last technical question, what do you enjoy the most about working with Angular at Google?
Okay, so it gives enormous satisfaction to work on a project of that scale and to see your code used by people. And also, being big means being close to making important decisions. I'd say these are my two selling points. If I wanted to convince someone, come work for Google in Warsaw, we have 100 Angular developers, here's what you will get. You will get to work on the largest Angular application. Everything you do will matter.
That sounds good. It was my last technical question. I have few more non-technical.
Few. Okay.
What kind of person is Łukasz? How do you see yourself?
I like to think of myself as being involved in many things. When there's something that excites me, I want to be part of it. And so I sign up for too many things at the same time, and then I regret it. But I try to be positive. I like to dig deep into technical topics and to understand what's happening. So I'd say I'm curious about the world in general.
Do you have some hints for us regarding self-organization?
Oh, so this is a big topic for me and a very difficult one. I tried, I think, all techniques that are known to humanity to organize my workflows simply because I tend to pick up too many things to do. And so what I would say, for managing your chores, I always like to use Getting Things Done philosophy by Alan, which just makes basic things so simple that you don't have to think about. At the same time, for doing work, this philosophy only works for some small tasks that don't require larger efforts. For those, I am trying out Cal Newport's deep work approach. I'm still not entirely sold on it, but this is the latest trend and I'm trying it out. Maybe I'll be able to tell you something about it next year.
Do you have any favorite hobbies?
I play the piano. not professionally, just as a hobby. And I actually returned to it once my kids grew up and they went for piano lessons, and I wanted to show them this is the way how you should practice. And it turned out I'm really into it again, and so now I'm taking lessons, and I'm slowly improving, and I enjoy it very much. I also bike. I took my family to the seaside this and last year. We bike for several days, stopping for the night at various places. There's a Eurovelo route along the whole Polish coastline that almost doesn't touch public car roads. So it's very safe, very beautiful. I highly recommend it.
Oh, super. Last question, favorite book?
Dune by Frank Herbert.
Oh, Łukasz, thank you so much. It was a pleasure to have you here, and I hope it's not the last time you are in this podcast.
Thank you. It was a pleasure too.
So for all of you, please smash the button, subscribe the channel, and see you next time. Bye.